Hey everyone, this lesson is part 2 of lesson 14.3. In this lesson you learn how to transform logarithms or logs in general. So I went over a total of 10 examples on this video lesson, so today we're going to finish up this lesson, but notice that I'm just going to have you read what I wrote for the sake of time. Okay, so the domain, which is the x values of a log function, will only be restricted by left and right shifts. So that means a graph, it moves the vertical asymptote. So it moves it to the left or to the right. So to determine the domain of the function without graphing, we use both set and interval notation in this lesson. So for number 11, okay, so this is 2 times the common log of x. As you know, the domain, there's an asymptote at x equals 0, which means we can't use 0 for the domain. So we can only use the values of x that go from 0 to the right, okay, not including 0, which means this is set notation in interval. You go from 0 to infinity. The next example, y equals log base 2 of x minus 10. So again, this minus 10 doesn't affect the domain, it only affects the range, but you know the range really doesn't get affected for logs because a graph keeps going infinitely down and infinitely up. So it goes to negative infinity and positive infinity for range, but for domain, this goes from 0 because there's no parentheses. Okay, so there's an asymptote of 0 on the graph, which means we cannot use 0. So for set notation, we say x such that x is greater than 0. Interval notation from 0 to infinity, again, notice this is a parenthesis, not a bracket, because we can't use 0. That's not included in the domain of that function. The next example, number 13. So this is 1/4 log of x plus 10. So now notice there's a parenthesis here. Okay, I'm sorry you couldn't see that. There's a parenthesis here. So for this one, since it's plus, it goes to the left 10, which means we can only use the values greater than negative 10 for the domain. So that's set notation x such that x is greater than negative 10, and for interval notation, parentheses negative 10 to positive infinity. Number 14, we have parentheses again. This is plus 7, so that means the graph gets translated 7 units to the left. The origin of the graph does. So then that means the domain in set notation is x such that x is greater than negative 7. Interval from negative 7 to infinity. What about when they give you the description of a transformation? Okay, so this is asking us to write a logarithmic function matching each description. So this one says the parent function f of x equals log base 2 of x is shrunk vertically by a factor of 1/5. So as you can see, there's a 1/5. And then it says translated 2 units up. So then there's a plus 2. And reflected over the x-axis. So then we must have a negative in front of the value, in front of the 1/5. Okay, that's going to make the graph reflect over the x-axis. Last example. This one says the parent function y equals common log of x is stretched vertically by a factor of 7. So that's where this 7 comes from. And translated 4 units to the left. So then that 4 has to be with the x inside of a parenthesis. So this is the function that represents these descriptions. That's all for this video lesson. Thank you for watching. Bye-bye.